Right. Okay. So in this little video, I want to show just a tiny little experiment that I made with Tone.js. So this is what it sounds like. I can just show you first. Okay, I think that's enough. And yeah, so basically it's a sequence that gradually updates notes in this sequence at random. And I thought I'd just go through the code and show you what it does. So yeah, I'm still pretty new to Tone.js, but I'll do my best to explain what's going on. So at first, I'm just creating a synth, a membrane synth. And then I'm making an array for the sequence that I'm going to use underneath here. But I'm basically putting 16 null values. And the reason why I'm doing that is that the sequence, it will divide, like it will take one measure, and then however many elements you have in the array, it will like space out things evenly. So if you want to have a 16-step sequencer, you need to have 16 values in this array that you put in. And null means no node, basically. Yeah. So then I create this sequence and I pass in this array here. And this is just the way that you kind of call that you do. So it will say like which node, which will be the value from the array at that index, and then the time that something Tone.js is using to determine when to play the sound accurately. So that's one of the reasons why you even want to use Tone.js, that they have this sample accurate scheduler. So yeah, here the synth that we created up here is being called, and it's this trigger attack release, which is basically just saying play the node. So attack and release is obviously like the envelope. Yeah. So after that, yeah, so here I'm just like, oh, and start, that's just the offset. So 0 means that it should be like at the start and not offset at all. And we have constant delay. Well, const is just like the variable, but delay, and I'm connecting that to the synth, and I'm setting the mix, so it's not too much, just a tiny bit of delay. And I do the same with the reverb. I'm making a channel. I'm not really sure if that was necessary in this case, but I just wanted to experiment with channels. So then I'm making a kick, which, I mean, it wasn't really necessary for this, but it was just to make it a little bit more like a beat. Yeah, and it's just every time, I think, yeah, it's just like a just every 8th note it will fire. Oh no, I actually put a probability, so 80% of the time it will trigger this kick. And then, yeah, just setting the volume. Then I'm creating a loop, and the loop is for updating the notes. So every measure, I will call this function update notes that I'm defining here. And start is, again, the offset. So if we take a look at update notes, I'm creating a new array based on the notes that I defined up here. And this will then, be the current version of the sequence. Then I'm looping through each element, and then I'm saying, like, if this random value will be above 0.7, and it returns a value between 1 and 0, then it does nothing. And if it's not, then it will set the new, like the index in this array to a random node, or call this, which returns a random node, which is down here, where I'm literally just saying, again, if this random thing is greater than 0.3, then we want to create a random note and a random octave, and then I'm returning both of them. So it's just a string saying like C1 or D3 or something like that. And if the value is, well, I guess if the value is greater than 3, it will do this, and if it's smaller than, it will return null. So there's like 2 probabilities in there. And yeah, I'm just doing setting the new array so that it's updated, and then I'm just console logging, which is happening out here. So yeah, that's basically it. And surprisingly, it is pretty musical, I think. Yeah, it doesn't sound too like disharmonic or anything. So even with completely random notes, I think, yeah, it's an interesting little thing. So yeah, I can just let it run for a little while. And yeah, but other than that, that was it.